Hi, and welcome to this video on error analysis. This first video will give you an introduction and a brief overview of systematic errors and error analysis. Whenever we make measurements always have errors. So the goal in making measurements is to minimize those errors, at least the ones that we can control. And the ones that we can't control, we have to estimate the errors that we are making. And then also, we need to ensure that our measurements are accurate and precise. The first type of error we're going to talk about is systematic errors. Systematic errors are ones that can be predicted on an individual basis, meaning that based on how measurements are made, in the past, you know that there are errors. Sometimes these errors are difficult to estimate, but with systematic errors, good calibration can remove those systematic errors. Here's some examples of systematic errors. For example, if you have a plotter or a ruler that has melted and elongated, then every time you make a measurement, it's going to be an error, and it's always going to be the same amount of error. Or if you have a scale that has not been zeroed, when you wake up in the morning and go to the bathroom and step on the scale, and it's off by 5 pounds every day, I know mine is off by 20 pounds, then that is a systematic error. Or if you're measuring time, and your watch its battery is dying, then it's always in error, and the error goes in the same direction every time. Systematic errors tend to push the error in the same direction. If you recognize the error, then you can correct it every time, and it can be done before you make the measurement, but also it can be done after you make the measurement. If you know that there is error, you can either subtract or add an estimate to correct the error. Random errors are a little bit more difficult. With random errors, they can't be predicted on an individual basis, and they're usually a result of sudden measurements or uncontrollable changes. Some examples of random errors, if you're measuring a time, the reaction time that it takes to start and stop your watch is a random error. Sometimes it'll be early, sometimes when you push the button, it'll be late. Or interpolation errors are also random errors. If you have a ruler, for example, that doesn't have many markings, then you have to estimate. And sometimes you estimate to the high side, and other times you estimate to the low side. Random errors are more difficult to resolve. They are typically randomly distributed. Sometimes they're high, sometimes they're low. And if you take enough measurements, then you can use statistics to estimate the error. So statistical methods are used to figure out the error, and this is why when we make lots of measurements, typically we measure the average or the mean. From that we can estimate the distribution and the error. Some examples of random errors: parallax. Parallax occurs when the scale and the indicator don't lay in the same plane. You're looking at the measurement from an angle. Another example is interpolation error. We talked about this already. When the graduations on the scale or the display are too coarse for precise measurement, sometimes your estimate's going to be high, sometimes it's going to be low. So that would be more of random error. So those are the two different types of errors: systematic errors, random errors. In future videos, we're going to talk about how to handle systematic errors and also how to handle random errors.